In the vastness of space, humanity has long sought answers to one of its most profound questions. Are we alone? Enter the James Webb Space Telescope, a marvel of engineering and a beacon of discovery. Launched on December 25, 2021. This $10 billion telescope has revolutionized our view of the cosmos. But despite its unprecedented capabilities, it has not yet found signs of extraterrestrial life. Why? Let's dive into the history, significance, and the limitations of Webb's search for life beyond Earth. The story of the James Webb Space Telescope began in the 1990s as scientists sought to build upon the success of the Hubble Space Telescope. Unlike Hubble, which primarily observes in the visible and ultraviolet spectrum, Webb was designed to focus on infrared light. This crucial difference allows it to peer through cosmic dust clouds and detect the faint heat signatures of distant exoplanets and galaxies. But why infrared? Because as the universe expands, light from the earliest stars and galaxies gets stretched into the infrared spectrum, a phenomenon known as redshift. Webb's infrared vision allows it to look further back in time than any telescope before it. Webb's capabilities go far beyond stunning images. Its primary mirror, spanning 6.5 meters, is coated in gold to optimize infrared reflectivity. It operates at a frigid -233 degrees Celsius, shielded by a 5-layer sun shield the size of a tennis court. This extreme cold is necessary to prevent its own heat from interfering with delicate infrared observations. With its 4 key instruments, NIRCam, NIRSPEC, MIRI, and FGS, Webb can analyze the atmospheres of exoplanets, searching for potential biosignatures like oxygen, methane, and water vapor. Even with these advanced tools, Webb hasn't found definitive signs of life yet. Despite its power, the search for extraterrestrial life is far more complicated than simply pointing Webb at a distant planet. One major challenge is distance. Many promising exoplanets are hundreds or even thousands of light years away. The further away a planet is, the harder it is to extract precise atmospheric data. Even with Webb's advanced spectrography, detecting biosignatures requires near-perfect conditions, including a planet transiting in front of its star in a way that allows its atmosphere to be analyzed. Then there's the issue of noise. Webb's instruments are sensitive enough to detect faint signals, but these signals must be separated from countless sources of interference. Stellar activity, background radiation, and even subtle instrumental noise can mask or mimic potential biosignatures. Scientists must gather repeated observations over time to confirm any hint of life, and this process can take years, believe. Another challenge is ambiguity. Even if Webb detects oxygen, methane, or other molecules associated with life on Earth, these chemicals can also be produced by non-biological processes, volcanic activity, photochemistry, and interactions between a planet's atmosphere and its star can all generate these gases. Differentiating between life and geology is one of the biggest hurdles in exoplanet science. Additionally, Webb's design places limits on the types of planets it can study. It excels at observing large planets close to their stars, hot gas giants, and mini-Neptunes. But Earth-like planets orbiting within a star's habitable zone are smaller and harder to detect. Finding an Earth twin around a Sun-like star, especially at the distances Webb can observe, is at the very edge of its technical abilities. While Webb has not yet found conclusive evidence of alien life, it has already transformed how we study exoplanets. One of its most significant achievements came with its observation of WASP-39b, a gas giant 700 light-years away. Webb detected clear signatures of carbon dioxide in its atmosphere, the first definitive detection of this molecule in an exoplanet atmosphere. This proved that Webb's instruments could indeed measure atmospheric composition with remarkable precision. Webb has also detected water vapor in the atmospheres of multiple exoplanets, including the intriguing mini-Neptune K218b. Although water is essential for life as we know it, The presence of water vapor alone is not evidence of biology. What's more important is how these molecules fit into the overall picture: temperature, pressure, and the balance of gases. Beyond individual molecules, Webb is helping scientists understand atmospheric dynamics, how winds, clouds, and chemistry evolve on alien worlds. For example, on WASP-43b, a hot Jupiter, Webb observed how temperatures change across the planet's day and night sides. This helps scientists understand if an atmosphere is stable enough to support life, or if it's constantly being stripped away by stellar radiation. Webb has also shed light on planetary formation. By analyzing young planetary systems, it can study the disks of gas and dust from which planets form. Learning how different types of planets emerge helps us understand what conditions make life more likely, or less. Importantly, Webb's data is being combined with observations from other telescopes. Hubble, Spitzer, and ground-based observatories provide complementary views in different wavelengths. By layering these data sets, scientists build a richer, more complete understanding of distant worlds. This synergy is crucial because no single telescope can do everything. While no biosignature has been found yet, every new discovery Webb makes sharpens the tools and techniques needed to find one. It's building a roadmap for future missions, teaching scientists how to recognize subtle patterns, and pushing the boundaries of what's technologically possible. In short, Webb has already revolutionized our understanding of exoplanet atmospheres, but the search for life remains a careful, methodical process, one that requires patience, creativity, and relentless scientific curiosity. Webb is just the beginning. In the coming decades, the search for life will accelerate with the launch of new telescopes designed to build on its legacy. The Nancy Grace Roman Space Telescope, set to launch later this decade, will specialize in direct imaging of exoplanets and conducting wide-field surveys to identify even more candidates for atmospheric study. Roman's coronagraph, a special instrument that blocks out the glare of stars, will allow it to image planets that would otherwise be lost in the brightness of their host stars. Further into the future, the Habitable Worlds Observatory, a proposed flagship mission, could directly image Earth-like planets orbiting Sun-like stars. This would be a revolutionary leap, offering the first chance to capture visible light spectra from true Earth analogues, something Webb cannot do. The European Space Agency's aerial mission, scheduled for launch in 2029, will focus entirely on studying exoplanet atmospheres, using Webb's discoveries to refine its targets and methods. Together, these observatories will form a coordinated, global effort to answer the question Webb has brought into sharper focus. How common are habitable planets, and what might be living on them? Webb itself will also continue to evolve. As scientists refine its calibration and analysis techniques, the telescope's sensitivity to faint biosignatures could improve. Webb's scientific program is planned for at least a decade, meaning its contributions to the search for life are only just beginning. In essence, Webb has opened the door, but the search for extraterrestrial life is a generational endeavor. Each telescope builds on the last, passing the torch of discovery to the next generation of instruments and scientists. One day, the first undeniable evidence of life may come from this very lineage, and it will owe much to the pioneering work of the James Webb Space Telescope. The James Webb Space Telescope has reshaped our understanding of the universe, bringing us closer than ever to answering the question of whether we are alone. While it has yet to find extraterrestrial life, it has provided the tools, the knowledge, and the vision to push forward. One day, whether through Webb or its successors, we may finally detect that first, unmistakable signal from another world. Until then, the search continues. Thank you for watching. Be sure to like and subscribe for more deep dives into our universe.